Tonight, we're going to be talking about the software quality triangle. And let's go to the next thing. First, I just wanted to talk about PNSQC, the organization. PNSQC is the oldest software quality conference in North America and maybe the world. Oops, I should have checked this. It's actually in its 41st year. Our annual conference is held every year in Portland, Oregon. Do you want me to mute that? Turn that down?
Oh, that's nice. Yeah, hard to.
It's all nonprofit. We're run by volunteers. We focus on the quality practitioner, so someone that's actually focusing on quality, but working in the industry every day. And we look for a range of topics and speakers, everything from automation, distributed teams, measuring quality, AI, ML, security, and enterprise quality. And a lot of times the talks that we're looking for are ones where speakers are describing their own experiences, not something where a consultant comes in and, has a pat story, but people telling their own experiences as they've lived through the events. Ways that you can get involved with PNSQC are you can volunteer. We need people to help write technical blogs or to edit the blogs. Right now, I think we have enough reviewers. Is that right, Heather? Yes. We have enough reviewers, and all those reviewers are reviewing the papers that the authors are working on right now. You can work with your company to become a sponsor of PNSQC, and I might mention that Critical Logic has been a sponsor in the past, and we appreciate that. You can also help put on events like this, the monthly meetup, or also help with the annual conference, and so on. There are lots of things that you can do to help with PNSQC. Just go to pnsqc.org and you can contact someone through that website there. And I just wanted to mention that the registration is now open. It's open right now just for the in-person conference, but this week we'll be also opening up for the people who want to attend the conference virtually. And we have a new venue. It's at University Place Hotel in Portland, in Southwest Portland, and it's attached to the Portland State University. And it's a very nice place, and we'll also have a block of hotel rooms for anybody that needs to stay at the hotel during the conference. So now I just wanted to introduce Bob Johnston. He's our speaker tonight. He'll be talking about the software quality triangle. And this is the beginning of the intro, and Bob can do the rest of it. Bob's a 25-year plus veteran of the IT industry. He's the creator of the IQM Studio automated test tool. He's also the CEO of Critical Logic, which is a sponsor of PNSQC at times. And he's a featured speaker at many software development conferences. And it's a pleasure to have him as a speaker here tonight for this meetup. So I'll let you, Bob, start in, and you can start talking.
Okay, well, thank you very much for that, Moss. I appreciate it. And hello to everyone in the room. And just to start out with a little camaraderie, I'm going to have a little sip of my wine just to pretend I'm in the room with you guys. So thank you. I'm actually sitting in Salt Lake City, Utah tonight, and that's where I live. And I have a couple other people from my company on a call tonight. Some other people may join. So, Critical Logic is here. So let me talk a little bit more about Critical Logic. That's right. I've been in the industry for a long time. Started back before automation was even a thing. We were doing testing, figuring out how to bring technology to testing. And I've worked for many, many different companies as a consultant. And back in 2006, I joined Critical Logic as the chief technical officer. And ended up over those years, decade or so since then, I've been become the CEO and owner of the company. So, but very much my roots and background is in practicing quality and testing and all the things about it. And critical logic is all about expanding that idea of quality way beyond testing into how you bring quality to software generally. And we'll be talking about that in this concept of the triangle. So actually, I think I'm going to start sharing my screen here first, if I can do that. Share screen. Okay. I'm sharing my screen. Can you see my screen? Yes.
Yes, we can see it. Thanks.
Okay, great. So I have a little PowerPoint as usual. You know, I badmouth PowerPoint all the time myself, but I find it very useful. So we're going to use PowerPoint to kind of drive this discussion tonight. And I'll tell you what I mean about bringing quality as a much bigger topic, much more than testing, to the software development lifecycle. Okay, so let's go ahead and get started. So this is the idea, this graphic here you're looking at. We kind of want to really simplify talking to people and clients and just people who are in the software industry about what are the key things to quality that from our point of view and our experience over all these years. And we'll be talking about intended behavior, which is probably a term you may have heard or may not have heard. We're kind of latching on to this term intended behavior. And it's meant to be a very broad sense of the word. It includes things like requirements and user stories and use cases and standards. And we'll talk a little bit more about that when we get there. But basic idea here is intended behavior is what does a business intend this software system to do? What is the reason we're doing this? What functionality do we need? Is intended for our users, for our customers, for our internal people? What's the functionality? What's the end goal? What's everything about the UX experience, the customer experience, whatever is incorporated in the intended behavior of the software, we mean that in the broadest sense. So in this triangle, that intended behavior encompasses a lot of parts of the software development lifecycle. And again, we'll talk about that as we go forward here. Then we're going to talk about development a little bit. Development is really not our focus here, but development is a very key part, obviously, of developing software. And you know, we're in the kind of quality business, and there are some quality issues and things to talk about in the development space. But what we're talking about is really outside the development space in terms of how to bring quality to the whole life cycle. And then verification, you know, we're using the word verification here very much on purpose, not testing. Testing is part of verification, but there's a lot more to it than that. And again, we're going to dive into that a little bit. So one thing I'll point out on this slide is the arrow directions, right? So this is an important thing. And again, we're going to talk more about it, but the arrows of intended behavior, it drives development. But what's an important arrow on here is that we profess, and we'll say and try to make the case, that intended behavior should also drive verification. And that's something that's a little bit askew in the industry right now. And again, we'll talk more about that. Okay, so let's go ahead and jump into some a little deeper into these subjects. So first thing I want to do is talk about, as I started saying, about intended behavior. One of the pieces of the triangle. From our point of view, if you don't get this right, you don't get it right, period. Nothing, if this is wrong, you cannot succeed in quality of the software. So what I'm trying to define here, the intended behavior, as I started to say, it includes all these things: user stories, security standards, data models, interfaces, legacy systems, this is all the things that compose the intended behavior and really that are the bits and pieces of the business needs. And I'm showing them here as fuzzy clouds because in almost all projects, these things are usually separately documented, not very well coordinated or linked together. They usually have different groups of people. There's different timelines to develop all these different things. But really the intended behavior, the way I'm discussing it now in the world today, or it can be this very kind of unorganized bunch of fuzzy things, right? And again, when we start talking about things like agile development versus, modified agile, all the different ways to develop software, these terms start getting also very defined differently. Like, the word requirements is not in favor. It's not really supposed to be part of agile development, for instance, but there certainly is intended behavior of the business. They may not call them requirements. They may be expressed as user stories or use cases or whatever that project is using. But there's also a whole bunch of hidden things that are included in intended behavior. Security I list here, but other things like UX standards. You may have, I may use this little example as we go through of a very simple example. The business is going to say, well, we have an account system for our customers log on to their account so they can buy things up our website. Okay, we're all familiar with that. You have to log on, you have to present some credentials, they have to be valid, you have to enter a password or token or maybe other things. There's a lot of different ways to log into systems these days. But usually the business will say something like in a user story, the user comes and logs in, enters the user ID and password, clicks OK. They may have an option to remember my user ID, things like this, all familiar to us, right? So the user might, the business user might describe that in a single sentence. Create a simple logon screen that has a button that says, remember me, right? So that level of information can go to development. And, I used to be a developer. I still am a developer, so I can badmouth myself a little bit. But that's enough for me. I can go build a logon screen that I know how to write code that will take in user ID and password. And I can put up some kind of error message if you get it wrong and so on. When I show you what I built, you're going to say, oh, that's not what I meant. And your error message, it really needs to say, please call customer support. And here's the phone number. There's a whole bunch of information that me as the business want to have in that logon screen and how it behaves when you have an error and so on. That information is going to be filled in by a developer if I don't tell them exactly what I need. Okay, now here I'm talking about a simple logon screen. So the idea that if I want what I want intended, I have to tell somebody, I have to tell development, and I have to tell testers how I want that in some detail. This is very, in my view, a very common problem and the root of many, many defects that make it into production or into deep into testing come from ambiguous or unclear requirements or specifications that came from the business. So the idea that what's happening right now is the business needs are expressed in all these different pieces, and they go together as kind of this mush over to development. Okay, so this is I'm kind of defining the way that things happen now. Some people do this better than others, but this is the landscape that I'm trying to explain here and how to maybe improve this landscape, thinking about things a little differently. So that's what I call intended behavior. So, I'm happy to make this interactive. Any questions or comments at this point as I go through this? I'm not sure how I would see a comment come across. Moss, if you're monitoring hand raises and stuff, let me know. But please feel free to ask questions as we go along. Okay, that's intended behavior.
Did anybody have a question?
Sorry, go ahead.
I don't think we had any questions here. I don't see hands raised.
Okay, great.
And no questions in the chat that I see. If
Okay.
anybody has a question, please put it in the chat.
Okay, thank you. So let's talk a little bit about development. Is development, whatever they're given in what I'm calling an intended behavior, and sometimes that's fuzzy. What development does is analyze and interpret what they've been given, right? They say, well, let's figure out if we know what we're supposed to do. And there's a lot of gaps and guesswork, and developers are very clever. If somebody said, well, they didn't tell us exactly how to, go from this screen to that screen, well, I'll figure something out anyway. So developers are very, development staffs are really good at kind of filling in details that they weren't given because they've done it a lot. They're experienced, they have examples, and they have code. They can look at other programs and ask other people in their department, how do you do this? And so that interpretation of the intended behaviors actually goes on, and they can actually write code even from very fuzzy intended behavior instructions. Okay, so and that results in they can actually go code, they can work through sprints, they can even probably develop a minimum viable product based on even sketchy or very fuzzy or incomplete behavioral instructions. Okay, they will then proceed to unit tests, sometimes system tests, but there's some testing going on here that's going on inside development that's very important. And it turns out when you study where the defects come from at a broad scale across all industries for many decades now, it turns out that very few defects that make it into production and release actually come from development problems or development errors. The bottom line is we know how to code. The message here is, for me, is we only will code what you ask us to code. Otherwise, we're going to make up stuff and we're going to fill in the gaps ourselves and we're going to deliver, we're good at that, right? So, but they're not going to be putting bugs in the clear directions we give them. They're going to be better off for sure, but we can give them very incomplete instructions and they will still develop software. It just, a lot of the content, functionality, and so on of that software is going to be made up by them, not specified by fuzzy intended behavior instructions. So what they do then, of course, is release that to test, right? So once we release the test, we're going to move on to the third part of the triangle here, which is verification. Okay, so verification is, everybody, it's very simple to say it's just testing, but there's a lot more to it than that, right? There's test planning, test design, test grouping, test scheduling, all kinds of stuff. Then we need to execute the test. Automation is, more and more common as a part of all of our verification. That adds a whole nother level of complexity to verifying what we're trying to verify. Bug tracking. At the end of the day, as the schedules proceed, there's excuse me, there's also going to be some assessment of the quality. Are we ready to release or not? Oftentimes verification, the QA group, somebody's got to decide, well, what's the release criteria? No level 1 defects or less than 10, however many defects, or every certain coverage level. There's a lot of things that are going to be developed here in the verification step that are activities and things that team is doing. Now, what's interesting though is to think about what's driving those tasks. Where are they getting test plans? How are the test designs being actually done, processed, and what are the criteria for designing tests? And there's so often today the testing is based on what software is in front of you. So here I'm going to talk a little bit about something really that goes way back to the beginning of automated testing 20 years ago, is capture playback. Anybody who's trying to do automated testing these days knows that capture playback is not very effective at creating useful tests. There's a lot of problems with they're really hard to maintain, they're hard to replicate. Plus, to me, the fundamental problem with capture playback is that you are capturing what the application is actually doing, right? As opposed to what it is intended to do. So if you record a test and play it back, it does exactly the same thing. It may be doing it wrong, but you're going to say that test passed because it did the same thing it did last time. Should it do that? If somebody said, no, that's the wrong thing, you misinterpreted the business requirement, that's the missing piece of capture playback. So what, sorry to get modern about this, sorry, my voice is going away. To get more modern about this is if you think about AI in testing and you talk about some other innovations in automation anyway called self-healing tests, what they are doing is they are assuming the application works correctly. In AI and self-healing tests are saying, well, we saw how it worked before. If it works that way again, then it's okay, right? If AI will analyze a recording or analyze behavior of users and come back and say, here's some tests you should run, right? But that's based on how the application is running, not how it should run. So there's some other problems with what I call testing against the does do. So you're testing what the application does do, not what it should do. So that's where intended behaviors come in. Because if your intended behavior instructions and documentation is very clear, then that also becomes a very important source of your verification steps, because then you can verify back to intended behavior where you're testing what it should do, not necessarily what it does do. And if there is a difference between what it should do and does do, you will only find that if you're testing against the intended behavior instead of what I actually see it doing, okay? So that focus there on intended behavior, that is really what we say and we profess. Our tools, our consulting services, we're all about making sure intended behaviors are very clear, and those intended behaviors are used to code and used to test, okay? So that to us is kind of the key to actually improving quality across the board, okay? So let's see how that comes together here, looking at the next slide. So that comes together like this, right? If our intended behavior is there and it drives development and our intended behavior also drives verification, then we have this triangle that leads to quality. Now, what happens though, if that intended behavior is not clear or not complete, or there's some ambiguity in that, that fuzziness enters the conversation between intended behavior, the business, and development. So that fuzziness then obviously gets propagated from development down to verification. And then if I go to verify, that fuzziness is also in the way of a problem that I can't really tell what's intended. So I'm not really sure what to verify. And there's another thing that happens. This goes back to my previous comment that you then start relying on what the application does do to verify, right? Well, it looks like this is okay. It seems to work. That must be okay. Let's pass that test, okay? But you're looking at what development did based on fuzzy information, okay? So that's a problem. The result of that is that you end up with releasing software that is in fact a business system, but very often you're going to say, well, wait, when I saw what we released, we missed a bunch of stuff and I forgot to tell you about this and that wasn't clear and you left that part out because I told you too late. All the reasons you end up with technical debt can be directly linked back to incomplete or not clear intended behavior instructions, right? This also creates risk. You're putting things out that aren't meeting business needs to customers. That failure at customer level when they find bugs or can't do what they want to do, or there's a missing feature, that ends up being something you absolutely don't want, right? I think we can all agree to that. So if we want to look at how do we get rid of these fuzzinesses, we have to have clear, complete, and unambiguous as possible intended behavior instructions that are passed to development and also passed to the verification team. Okay, this ends up, when you do that, you end up with the business system you intended. Okay, so that's our message. That's what we profess is, in our experience, so much of industry's problems in defects and missing features and just not quite meeting business needs right, all come from failure, or let me say lack of emphasis on creating clear, complete, and unambiguous intended behavior specs. Okay, so let's look back. How can we address that? Let's talk about some ideas on how to make intended behavior better. Okay, so the business needs, as we saw before, is this kind of fuzzy box of things. So I think you need to set out goals that start saying that we need to be able to have a single agreed upon statement of intended behaviors. Now, a statement obviously is not just one thing, but it's going to be a collection of documents and other things that all the interested parties have said, yes, we understand all that. And yes, we reviewed it. And yes, that is what we intend to do. And there may be some negotiation of cost and schedule and so on, but there needs to be a agreed upon business needs statement called intended behavior from all the parties involved. So that's the business of the sponsors, even user groups if you have them, development and testing, verification teams. If you can come to a single agreed upon statement of intended behavior, then pass that to development, you're way ahead of the game automatically and from the beginning. Okay, so moving on to how do we do that, right? Let's talk about some hallmarks of intended behavior that reach those goals. Okay, so they must be clear, complete, and unambiguous. They must be maintained and maintainable and maintained. That means we have to have control of all the documents and all the places, who owns them, what version they are, all that kind of stuff, and maintain that set of intended behavior documents as a single thing, right? And every time one changes, we have to understand the impact on everything else. And that is an important but arduous task that is often never done. I mean, how many times have you seen applications, they develop something from some requirement spec, and then the development continues to evolve, but the specs are left behind, and they lose control of what's really intended, except by looking at software, because they have not maintained that intended behavior documentation. Really important too is they must be signed off by stakeholders. If you have stakeholders who aren't aware of changes or don't know the impact of that change or haven't assessed that, you've got a big problem that's going to happen in the quality and some, technical debt and other things that the business needs will not be met if you don't have all the stakeholders signing off on intended behavior. Okay? So, and they also must be the source to development, and this is really important, that intended behavior must also be the source in the tests. So the test knows what should be happening when they test the application and compare that to what really is happening. And that's a little bit harder, a little different process than most test teams take on now, but it's so important to get testing back to the intended behavior instead of testing what I see right in front of me, okay? So both of those things need to go into test. So how do we do that? Well, in our business, and I'm not going to talk a lot about what we do as a company, but everything I'm telling you here, our reason for being as a company is to make what I'm telling you here possible in software development and systems shops that are building the software. Okay, but here's some ideas for you. Modeling. There's a lot of different ways to model. We model, our technology is all about modeling. We call it cause effect modeling, and it does things that really increase and improve the quality of your intended behavior statements, of your requirements. Make sure your test cases are actually testing what you intend them to test. And there's a lot of other things that our technology does, but there's lots of other modeling technology, right? There are all the modeling like activity diagrams and flow, all kinds of flow charting. There's all kinds of modeling tools out there, and more all the time. But anytime you can draw a diagram or a picture or a data flow diagram, these things are all very important in getting buy-in and creating clarity and making sure you can find missing pieces and any kind of conflicts when you're developing this stuff. And prototypes. Prototypes is another very powerful thing that will help you verify your intended behavior is being communicated to all the people, all the stakeholders, and all the developers. Okay. So one thing we do is, again, we advise everybody does is follow the BABOK, the Business Analyst Book of Knowledge. Okay. So that BABOK is very good at defining very clear, distinct processes, how to define business needs in very important and structural way that can be maintained, understood, passed along, and looked back and archived. These are very important things so that business analysts, many projects these days skip or shortcut business analysts as a step in their software development. But in our world, it's the most important step. It's the step that makes sure that we elicit behavior requirements from the users, from the business, that we state those in a way that is very clear, regimented, documented, and can be clearly communicated to other people. So that BABOK, and there's other standards for analyzing and documenting business needs, but we adhere primarily to the BABOK, which is helped tremendously in us achieving our goals in creating intended behavior statements. Another kind of key thing that really is the hard part of trying to improve your intended behavior is extending schedules for requirements. Everybody talks about move left. Everybody moves left a little bit, but what does not move left very often is budgets. People will say, yeah, let's start earlier, but they don't move budget earlier, right? The budgets still are all usually for development at the end and testing. And oh my God, we're testing nightmare at the end, hire testers. So budgets tend to swell towards the end of projects. Where they really need to swell to attack this problem is at the beginning of projects. So that investment at the beginning, extended schedules for requirements and extended budgets, is something that's a little bit hard to sell, but it's something that is required to get these intended behavior statements to the quality they need to be to impact the eventual delivered system, right? Another concept that is very important to us as a consulting group is testability of design. So we make sure when we're designing things, whether it's a data interface or user interface or an interface between systems, anything like that, we're always thinking, okay, how am I going to test this? How can I prove this is working? How can I prove, I don't want to see any hidden things that are going on where I can't tell, I can't verify that function worked correctly. There needs to be, observable effects of everything we're doing somewhere. So thinking about that when we're designing things, when we're saying, this is what's supposed to happen in a business rule, here's how I can see the effect of that and make sure that rule was actually executed correctly. That's testability. That's something, when people are writing down user stories and telling people what they want their system to do, it's very often overlooked how to tell that actually did it, right? In a way that is not too late. Like, we can say, wow, we're going to issue paychecks and all the payroll is going to run, everything going to happen, the checks are going to get printed and sent to the employees. And then how do I know it worked? Because the employee's lawyer called me, right? That's how I know it didn't work. You need to be able to figure out testability along the line before you get to that point. right? And then measure results and coverage is another big thing that it's very hard to do, measure results and measure your coverage. Coverage means, have I tested everything that was written? Have I tested everything that was intended to be functional? And if you don't have very clear intended behavior requirements, then it's very hard to tell what your coverage is. Because, oh yeah, we forgot that one feature, but we talked to the programmer and they programmed it in. Well, that coverage of that feature is going to be missing when you go back to say, what did we test? Did we test everything? Well, I don't know, because we added features that weren't documented and we didn't code all the features that were documented. When you start having that, you've lost control of your coverage. You really will have a really tough time determining what the quality of your software is unless you can measure your results. I ran how many tests, and that test covered this much of my functionality. If you can't answer those questions with real hard data and real linkage back to requirements and test cases and behaviors, you really are guessing when it's time to release. And it's really sad to see, and so many bad things happen when releases are based on schedules, right? I know we can't test anymore. We got to release this month. We got to release without the really, can we release? Should we release? What's the impact of releasing without good business, meeting good business needs? So all of that stuff. So some ideas there. Those are my takeaways for you. There are ways to improve this intended behavior. I'm hoping I'm making the point that it's worth investing in improving intended behavior. And that's really what this is all about. Okay. So given all that, if you do those things, you can get to this intended behavior triangle that we talk about. And that intended behavior triangle can deliver to you functional business systems that actually meet business needs. Okay, so that's my talk for tonight, and be happy to discuss or talk about or answer any questions you have about what I said.
Thanks. Thank you, Bob. We had a question in the chat there that says, I don't know if it's a question or not. It says, Ryan asked, without clear intent, you also leave customers and customer support to make up their own expectations, which are likely to not line up with the business or leave the business chasing the wind. I guess that's more of a comment.
Well, absolutely. That is exactly the idea. I mean, I said at the beginning that our idea of this triangle is to really make this simple, right? There's just trying to make it simple, but of course there are customer support and there's release cycles and DevOps and there's enhancement cycles and customer feedback and customer satisfaction, UX design, and all those other things are of course subject to the same problems. But again, we're trying to talk about this very simply. So your point is really well taken, Ryan. Absolutely.
I had a question how would your single agreed upon statement of intended behavior work for a team that uses agile development where they're trying to iterate on the behavior?
Well, that's a really good question. I think the product owner in a agile environment, the agile team themselves will they're almost operating kind of in a micro piece of this, right? I think the owner of the product has to have an additional, above the agile development cycle, have additional tools where we're saying, okay, we have this intended behavior library, if you will, or we know a big picture, everything we want to do. I would call those requirements, but most agile people will swear at me when I use that word. So what I want to say is that what happens is you have to pick pieces of your intended behavior that are clear and ambiguous and put those into each agile cycle, right? Say, okay, this sprint, we're going to work on these user stories or use cases, but those use cases, user stories need to come from that larger clarified, agreed upon intended behaviors set of documents. So, Agile has this, I think it's a flaw that they think that they only have to think about this sprint. And that sprint has to have a context here. And that context has to be bigger than a single sprint or even a single Agile project. That is the business requirements. And the business requirements have to transcend across multiple Agile sprints and scrums. So they just, if there's somebody that I'm talking to in the Agile world about that, they all no, you don't. And okay, let me just say, you can probably do it without it, but you're going to end up with the results that I'm talking about, with lots of unintended behavior, with developers interpreting intent and saying, is this right? And the business saying, no, that's not right. That's not what I intended. And can Agile handle that? Yeah, that's why Agile exists. So when you make false steps or you kind of iteratively find your way to the truth by making a lot of mistakes along the way. But if you know the truth in the beginning, even Agile becomes much easier because you have less of that. Oh, you didn't do the right thing. That's not what I meant. So that's my answer about Agile.
Thank you. Does anybody else have a question for Bob? Oh, here you go. Go ahead and ask the question.
Hi, Bob. Thank you for your presentation.
Sure.
On your AI comment, if you feed AI the intended behavior, why wouldn't you preclude the shortfall that you had described about AI?
Well, yeah, okay. I could talk all night about AI because there's definitely some great promise there. But what I mean by that is that if you input software behavior into AI and say, hey, look at this behavior, tell me how to test it. That if that behavior that you put into AI is not what the business wanted, AI doesn't know that. And it will tell you that the system does, here's the test you need to run to prove the system does what it does. Okay, that's my point. Now, what I am looking for, I haven't seen anybody really talk about this yet, is where AI is going to make a huge difference, is where AI can take as input the intended behavior, the statements of intended behavior, the data flow diagrams, the cause effect models that we produce, state diagrams, when it can take those things that the business says, this is what I want. And then if AI can take that and tell you how to test it, now you've got something. All the AI examples and demos I've seen so far, which isn't a lot, tell me that what AI does is I think one of the more popular ones, it will observe actual users and how they use the software, right? It will come back and make conclusions and suggestions based on what it saw actual users use the software and ways to test it and ensure that what they're doing still works, right? But if it's not what the business wants, or if there's some flaw in that logic or behavior, AI is not going to know that. And in fact, it's going to perpetuate it. And it's going to tell you, hey, the system works great, but it's not going to tell you it's not doing what the business wants. So that's really where my comment about AI came from.
Thanks. We have another question here. Sure. I'll produce the feedback.
Hi, this is Ying. I'm one of the board member. Thanks for sponsoring PNSQC.
Yeah, welcome.
And one of your colleagues did a great paper one year on modeling, and I referee that paper. And thanks for putting some rigor and emphasizing the importance of modeling in this presentation. So anyway, my interest in, because of my work, emphasized a lot on complex system and large enterprises. And one of the big issue, of course, is in very big systems, there would be many related subsystems that need to be integrated together. Often the individual system subsystems is already hard enough to verify functionality. And there are different dimensions of functionality. There's business functions, performance and technical related functions. These days, increasingly, we have security related functions, accessibility requirements to support diverse communities. To put it briefly, I think nobody really understands all the requirements. You can't even get them all in one room in large enough systems, supporting large enough user communities, say an entire nation or an entire state. So my question to you is, you talk about intended behavior, and with these type of complexity, there will be many aspects and many dimensions of such intended behavior. And how then do you model and support, never mind all the possible combinations of feature, but just the happy paths? I mean, what judgment do you make in this process of the triangle? And you know, in my circle of quality management, we usually talk about verification and validation. You emphasize in your diagram verification. Obviously, we want to validate that it meets business needs. That's usually the distinction between verification is build as spec versus build as intended or fit to use is validation. Yes. So anyway, these are all related and in the sense of the complex system with the many dimensions of intended behavior.
Right, right. Well, that's a really great question. So you're really asking, how can you apply some of these ideas to the complexity of the real world, right? So, and let me start by talking about validation, because you brought it up. It's a very important thing to us as well. One of the things that modeling does, and any kind of modeling, and any kind of stakeholder review or sign off, does what we call validate, right? So in fact, we will often say that you cannot build a model of some behavior or a diagram of behavior. Or let me say it this way. When you build that model, that validates the input to that model, right? The input might be somebody's idea, somebody's head, it might be some requirements or user stories, it might be some legacy functionality, who knows what the input to that model is. But once that model is built, that model can push back and validate, or even better, find problems with the input and requirements. And that validation becomes so important, because just the act of modeling actually creates validation on the input to that model. So the important point there. Now to the other point about how in very complex system, interactive systems with interfaces at your API level, and getting into AI now. I mean, how do you test AI stuff? I mean, these are really difficult situations to test. But what we typically do is we try to break things down into manageable projects, if you will, where there's some criteria about this needs to improve. So if you have a set of functionality that's very buggy, or has low customer satisfaction, or is hypercritical in your functionality, or a good candidate for trying to use this model to improve intended behavior is new functionality, right? So it's very incremental. I mean, you cannot, I'm not saying you can have this intended behavior for a single statement of intended behavior for a missile launch system, right? But you may have many pieces of that complex system that are important enough or problematic enough that you can trace back the problems you're having to poor intended behaviors. That's a candidate for doing this. Clearly, over time, you might have significantly more and more pieces of a complex system where you've captured the intended behavior in a good way. But most likely, you're not going to get all of it. So I think you need to pick and choose, set yourself up some criteria about where your risk is, where your opportunities are, where this is important to get it right. And then that's where you start with small pieces. Did that answer your question or ask, prompt more questions?
He holding up his thumb. Jason Arbin had a note in a comment in the chat about oh, I lost the thing. About an AI system that will review BDD like intended behavior and generate tests. Is that right, Jason? I missed the.
Hi. Yeah, I presented at PNSQC, but that was like 80 years ago. But there are some systems that take BDD like descriptions of expected behavior or intended behavior, and then try to execute to validate that. Execute the product to validate that those intended behaviors are working. There's some, not most are not that though. To be very clear.
Yeah. Well, that's I'm glad you brought that up. I mentioned that I wanted to say that I think that's a really good direction for AI. BDD has its own limitations and problems, of course, but that's a great start. I mean, that is further back than just looking at the actual software behavior. So yeah, that's coming. I think those are the ones that are actually going to be effective tools. I think, what's happening. Let me say, there's some people in my company and some of my partners and just people around that know what our tools do. We have been tempted to call our tool AI, but it's not. Our tool does a lot of things I'm talking about here, but it does it through algorithms. It looks at mathematically, if you can draw a diagram that has, it's like a circuit diagram, really, with has logic in it and so on. We actually have an algorithm that can look at a diagram and say, here's the thing, here's how to test that diagram. Here's all the ways you can get through that diagram, different options and possibilities. And if you want to test if everything's working right, here are the tests you need to run. So we do that through a very complex algorithm that's based in a lot of kind of complex mathematics, but we don't call that AI. That's just algorithm. And I think some people who are saying they're doing AI are stretching the term a little bit, but there's no question it's coming. I'm looking forward to AI actually being able to read a document or interview a user and elicit requirements for a user conversation, and then turn that into tests and software. That's coming, but I don't think we're there yet.
Have a question, Bob? I heard some disbelief when you guys were when he was talking about getting all the intended requirements together or intended behavior together.
Yeah.
Do you want to comment on that?
I mean, sure.
So that's
Yeah, hi. My name's Ray. I'm a tester, a QA analyst, and to me, the biggest issue is getting good requirements. I mean, it's a losing battle, it seems like to me. And the more we go into the future here, everything's got to be quick. There's just no time to go back and revisit the requirements. In the meantime, development already has it. By the time it gets to me, I'm not sure what the heck to test. But I do know one thing. I'm not going to, I still try to go to whatever requirements I have, and that's what I test against. If it's new functionality that I'm testing, of course. If I'm doing regression testing, it's more like what you said, that, hey, my only choice is to compare my test today with how it worked, like, let's say, before the new service pack went in or something like that. Then it's pretty much that's what you do. But anyway, I just wanted to say it's good luck getting everybody to sign on together.
well. Let me just agree with you 100%. This is another reason and mission of our company is we understand that the limitations of human beings to analyze a complex set of requirements and in a very, very short period of time, pull out a bunch of tests that's going to test everything. And then what really, I think you're alluding to this, is that when that behavior, that system changes, you enhance or add a new feature, what's the impact on regression? How do I know what it's supposed to do anymore? You've made one change to the system, you give me a week to figure out if it still works. You just blew up 300 regression tests that I don't know if they still work or not. I know those problems. I've been there myself many times. So what our company and our technology is trying to do is automate much of that problem. So if you can create, and I'm not really prepared to show this or anything today. I'm trying to stay non-commercial here, but what we do, and there was somebody else in the audience who talked about the paper that we have about modeling. That paper describes this really well. What we do is build models of the behavior so that when you change that model, the model figures out what tests you need, what needs to change, what tests are no good anymore. And they can literally do that in seconds. Something that would take maybe a person weeks to do. We can look at, hey, this behavior changed. We have 800 test cases that test that behavior, but it changed now. What happens? We can very quickly come around and tell you, well, most of those tests are so good, but these 10 are terrible. You need these new 20 tests. And we can tell you that through our algorithm and that model in literally seconds. So the kind of problem you have, we think is unsolvable with human resources unless you give a whole bunch more time than you have to do it. So you need tools. There are tools like ours. There's others that do similar things out there. So I'll encourage you to look at tools that help you generate test cases from requirements that are built in models, or generate automation code automatically for you. All of that, there are tools out there that do that kind of stuff, including ours. So yeah, I think the battle is between robots now. We have to have technology to keep up with the technology. It's getting beyond the human capacity to keep up with the complexity and the pace. So a lot of sympathy, but there is help out there.
Developer, I happen to work on a product that has regulatory requirements to deal with, so that helps us along. You mentioned release criteria, and the thing that came to mind is, what about acceptance criteria? How do you manage it? How do you make sure everybody agrees to it? And I in my mind, stories are requirements, and stories have acceptance criteria associated with them, which makes some requirements. So how does that slip into this whole ball of wax here for you? Yeah,
well, what we often, again, I think the key to this is, well, I keep using the word model here, and I mean it in a broader sense. Any kind of, what you need is a view of that story that people can understand without ambiguity, right? So a really well-written story can meet those requirements. But if you take a story and try to diagram that story, you say, well, if this happens, that happens, this is happening, when that happens, this doesn't happen, this should never happen, this should always happen. When you take that kind of analysis to a user story that's, plain English in sentences, and there certainly are good and bad ways to write user stories, but any user story can be broken down into logical decisions that are happening within that story. If I do this, this should happen. When I do this, this should happen. When the user doesn't do this, or when the user is this type, this should happen, including the main story and the different versions of the story. All that stuff has logic in that. And if you can expose that logic, extract that logic out to a picture, a model, a diagram, then people can look at that and there's no ambiguity in the picture, right? So there's no, the words are gone, the words are still there, but a lot of the ambiguous words are gone. So diagramming, even simple tools like Visio or drawing it on a whiteboard, those take a huge step towards clarifying what that English language means, okay? So modeling is what I'm going to say is the way to get buy-in from multiple people more easily than people reading English statements that may have ambiguity or innuendo.
Me, that sounds a lot like the expounding on use case.
I'm sorry, I don't think I heard that.
Oh, what you described sounds a lot like expanding in use cases.
Yes. Yeah. So, I mean, in our practice, much of our modeling is based on user stories. Like we take a user story, turn it into a model, validate the user story with the model, then that model becomes a source of truth for what's supposed to happen in that story. And then we can say, okay, here are the test cases, the acceptance criteria for that user story, and we can generate that from that diagram.
Does anybody else online or in the room have any other questions? I don't see anything else in chat right now.
I have one more.
Oh, one more hand raised in the room.
Hi, this is Ying again. I'm very interested, from the perspective of you, of course, having a test and software oriented business. When, because I'm with the state, we often require our contractor to provide deliverable based proposals. And our contracts are always done deliverable based. I'm kind of wondering, the compatibility of that type of approach in an agile methodology, because I think often the formal contracting and agile has a degree of incompatibility, especially when it comes to well-defined milestones to perform well-defined testing. So it's just interested in your comment on that.
Yeah, again, there's different agile, obviously. Some of what I'm saying just doesn't seem to fit well into agile, right? I mean, there's just there's certain approaches to agile development that, that's why I call this intended behavior. It was tempting to call this requirements, but that immediately was, counter to the manifesto of agile. So let me say that some of our clients, let me say it this way. When we have clients that have offshore or third-party development, this message, in fact, this triangle message that I'm presenting tonight came out of a discussion I had with a guy who runs a very successful company here in Utah. But he was about to turn to offshore for his development work. And I said, okay, listen, you have to get your intended behavior correct to be able to take this out of your shop. Right now, your user can walk over and talk to the developer. You can have meeting every day in the same time zone, all the same times that you can make it through with bad intended behavior. When you have a very close working team. But when you send that to an outside group, this becomes even more important because they're going to take whatever you give them and deliver. They have a schedule. They have a contract that says what they're going to deliver. And if you're not really clear about what you want, you're not going to get what you want. And you're going to start a dispute that, hey, I read what you gave, I followed the instructions, I delivered it to you, but it's not what I wanted. Well, guess what? That's your fault for not being really clear on your intended behavior. And that is often the default and the overrun and the conflict that happens between contracted development and businesses, that businesses are not well equipped to provide the super clear intended behavior. That's a missing piece. And that's really my whole intent here, especially when your development is not in-house. This is even more important.
Great, thank you. I think we should probably wrap up the talk now. Thank you for your insight and wisdom, and also thoughts beyond, about intended behavior. I just wanted to, let's see, what do I want to do? I wanted to mention to everybody that the PNSQC registration for the conference is open now. So you can attend that, or you can go to that and, well, I'm going to stop sharing Bob's screen and share my screen just to say thank you. And I put a link to the registration for PNSQC 2023 in the chat, and we're opening the in-person registration is open right now, and within the week we'll have the virtual registration open as well. And we're also looking for anybody who thinks their company could benefit from sponsoring PNSQC, or so if you're interested, go to pnsqc.org and reach out to anybody there. And we don't have a topic for next month's meetup, but it will probably be one of the invited speakers for the conference giving kind of a teaser talk on their talk at the conference. And let's see, we have some good keynotes lined up. We have Andrea Goulet, who will be talking about empathy as a technical skill. We have Selena DeLessi. Carl Wiegers will be there talking about requirements, the 20 essential requirements that practices that you need to know. And let's see, there's one more keynote. Oh, Jan Kanagiter will be there talking about what his exit on the highway to hell. So,
How we got booted out of his job for going to the conference.
yeah, okay. How he got booted out of his job by going to a software quality conference. Okay, so I think that's about it. Thank you to everybody that could attend in person and online. In person, we'll finish up some food here. And thank you to the people that could attend online.
Well, great.
And,
Moss,
yeah.
I just wanted to point out that we will be at the conference. We will have a booth there. So if you're interested in anything I said about our stuff, we'll actually be, I won't be shy about telling you how great our stuff is at the conference. So anyway, yeah, I really appreciate everybody. The questions were great. I really appreciate you having me on, Moss. I enjoyed it a lot.
Should have driven down. Okay.
And if I could make a little personal shout out, I want to shout out to one of our employees, Lisa Cominetti, who's joined the call tonight. I just want to say hello to Lisa. Yeah.
Thank you. I thought I was being incognito.
Unfortunately, your name was listed in attendees, so I saw you were there. So.
Oh, wonderful. I really enjoyed this. Thank you so much. Really aligns with my values. So pretty excited.
Yeah. Yeah. Great.
Thank you.
Right. Thanks, everyone. And see you later. We're ending.